So, hello everyone. Today we're gonna uncover what a discriminant means. So we know so far what a quadratic equation means, and a quadratic function is something that's written in such a form. And the expression here, we've already seen this expression in the quadratic formula, but it has a specific name, which is the discriminant. So we call it a discriminant in mathematical terms. So the value of the discriminant is wise before plugging everything into the quadratic formula is to find the discriminant. Then we do that step because um, its value, it tells you how many roots. It tells you if the equation actually have roots or doesn't have, or it has one or two. So in the case the discriminant is positive, fx has two distinct roots. In the case when it's equal to 0, it only has one repeated root. And in the case when it's negative, and we have seen that in one of in our I think the previous one of the previous session, when it has no real roots, so we can't solve it. And yeah, it has no real roots when it's negative. So you can see a is the coefficient that is related to x squared. So when a is more than 0, we know the parabola takes this shape where it actually has a minimum. And when a is less than 0, it takes this shape, like a sad shape. Anyways, this is just telling you the general form of the parabola, which is the curve. The curve of a quadratic equation is called a parabola. That's what a parabola means, if you've forgotten. So when we have two distinct roots, it passes through the graph and it crosses it at 2 points. When it has one repeated root, in this case here, it crosses it at 1 point. So the minimum crosses at 1 point. So the minimum is the same point where the graph crosses the um, x-axis, as you can see. And when there is no real roots, the graph will be upward like that. And the same thing, same logic is in here as well. So you can see it for yourself. Anyways, let's do example 13, where we're going to find the values of k for which f of x, x squared plus kx plus 9 has equal roots. So we know that the discriminant is equal to b squared minus 4ac. So in this case, b is k, so k squared minus 4, a is 1, and c is 9. Okay, so k squared minus, I think, 36. And we want to find it for when it has equal roots. So when does that happen? When we have one repeated root, that's when we have equal roots. So in this case, so when it's equal to 0, so we set this one to be equal to 0, which is the same thing as saying k squared minus 36 equal to 0, which is, if we were to solve it, k squared equal 36, which is k plus or minus. So here we found the values of k as required for the instruction of example 13. So let's move on to example 14, and where we have to find a range of values of k which x squared plus 4x plus k equals 0 has two distinct real solutions. So in this case, let's find the discriminant. The b square, so 4 square minus 4ac minus 4, 1, c is k here. So it's 16 minus 4k, right? So the condition is when it has two distinct real solutions, so it falls into this category over here. So when it has two distinct solutions, when theta, I think the discriminant is more than 0. So we don't call it theta. I forgot. I think it's delta. I think it's delta. We call this sign over here delta. So 16 minus 4k more than 0 that if we solve this inequality, we'll have 16 more than 4k, and then k. I'm just like flipping the sign. So we know 4k is less than 16, so k is less than 16 over 4, which is k is less than 4. So this is the range of values of k for which this equation over here has two distinct solutions. Okay, so today we're gonna do two more questions of the exercise sets, which are similar. So the ones we've just done now. So we have find the values of k for which x squared plus 6x plus k has two real solutions. So this is true when delta is more than 0. So we need to first find delta. So delta is equal to b squared minus 4ac. B in this case is 6. So 6 squared minus 4 times 1, k. Okay, so that's 36 minus 4k. So we solve for delta more than 0. That is 36 minus 4k more than 0. 36 more than 4k. 36 over 4k. K is then less than 9 because 36 is 9 times 4. So, and here I'm just flipping it, so it's the same thing. So the values for which k has two real solutions in which are k is less than 9. So find the value of t for which 2x squared minus 3x plus t is equal to 0 has exactly one solution. So in this case, we'll find delta. So what is delta? Is b squared minus 4ac. B is minus 3, so minus 3 squared minus 4 to e here. So that's 9 minus 8t. So it has exactly one solution. So we're solving for, so that means it has like one repeated solution, whatever. So that's when it's delta is equal to 0, which is 9 minus 8t equals 0. And we solve for this one, and it becomes 9, 8t equal 9. So we move 9 to the other, 8t to the other side, and then we solve for t, and becomes 9 over 8. So the value of t for which it has exactly one solution is 9 over 8. And you can see when it was values, we actually found values. And when it said the value, so that means one value, and we actually found one value. So generally, in the textbook or in the exam, they're being very specific when it comes to how many solutions you will find. If they said one or so many solutions, that's when you have to make the, but if you know your stuff, you know it. And this should mark the end of our session. I shall see you in the next one. Bye.